Welcome back to my class in statistics. Today we will take the last two measures of central tendency, the median and the mode. We have taken the first of the three measures of central tendency, the mean, or simply or also known as arithmetic mean. And we have also taken some types of means, including geometric mean, harmonic mean, weighted mean, and combined mean. And you must know that mean is an average, and the median and the mode are also averages. So the three measures of central tendency, the mean, median, and mode are all averages, but the most popular is the mean. But some people may not know that the median and the mode are also averages. The median is defined as the middle score or the middle value. When you arrange the scores in ascending or increasing order, you will find the median exactly at the center of this distribution of values or observations or scores in ascending or descending order. And the median has the property that at most half of the observations or values or scores are below the median, and at most half of the observations or values or scores are above the median. Thus, the median divides the set of data into equal parts. And we consider two cases for finding the median of a set of observations or values. The first case, we consider an odd number of observations. For computing the median, we consider two cases. The first case is the sample size n is an odd number, that is the number of values or the number of observations in the set of data is odd. Example, consider the set of numbers 1, 7, 5, 3, 8, 11, 6. We have 1, 2, 3, 4, 5, 6, 7. N is 7. And 7 is an odd number. To find the median, the first step is to arrange this set of numbers in ascending or descending order. I will use ascending order, that is from the lowest to the highest value. The lowest value is 1. The next lowest is 3. And then 5, 6, 7, 8. And the highest value is 11. If the number of values in the given set of data is odd number, when you arrange the scores in ascending order or descending order, you will find exactly one value at the center. And here the number exactly at the center of this arranged set of data is 6. And this value exactly at the center of this set of data arranged in ascending order is already the median. The median is 6. And you can see the median 6 is found at the center of this distribution of scores or values. And you have 3 values above the median and 3 values 3 values below the median. And we have 7 values. If you divide 7 by 2, that's 3.5, or if you round it up to whole number, it's 4. I said earlier that the median has the property that at most half of the values are above the median, and at most half of the set of values or observations is below the median. And half of the 7 observations is 3.5 or 4. So this means that at most 4 of the values in this set of data is above the median. And this example satisfies that property of median. We have 3 values that are above the median and 3 values below the median, and that satisfies the condition that at most 4, maximum of 4 are above the median, and at most 4 or maximum of 4 are below the median. In this case, we have 3 scores above the median and 3 scores below the median. For case 2, we take the sample size as an even number of values or observations. We consider the case where the number of observations or values in the given set of data is an even number. Consider the following set of numbers. We have 25, 19, 18, 23, 20, 18, 17, 12. And we have 1, 2, 3, 4, 5, 6, 7, 8 values. And the sample size n is 8. And 8 is an even number. As in case 1, where the number of values is odd, the first step to find the median is to arrange the data in ascending or descending order. And I will arrange these numbers in ascending order, that is from the lowest number to the highest number. The lowest is 12, and then 17, 18, there are 2 18. There's 19, 20. $23 and 25. We have 1, 2, 3, 4, 5, 6, 7, 8. Now, after you have arranged the set of observations, the observations in ascending order or descending order, you locate the two middle values, or the two numbers at the center of this distribution of scores or values or observations in ascending or descending order. But to find the two values at the center, at the middle of the distribution of data easily, we divide n plus 1 by 2. Our n is 8. Plus 1 divide by 2. This is the easier way to locate the middle score in a large set, in a set of data with large sample size. You divide n plus 1, you add 1 to the sample size and divide by 2. In this example, our sample size is 8 plus 1 is 9 divided by 2. 9 divided by 2 is 4.5. Now, the greatest integer less than 4.5 is 4. And the smallest integer greater than 4.5 is 5. Again, n plus 1 divided by 2 is 8. 8 is the sample size. Plus 1, it's always plus 1. And the sum we divide by 2. 8 plus 1 is 9. Divided by 2 is 4.5. And you take the greatest integer less than 4.5 and it's 4. And then you take the smallest integer or whole number greater than 4.5 and it's 5. The two middle scores now are the fourth score and the fifth score in the distribution of scores or observations arranged in ascending or descending order. Hence, from 12 we count 4. We take the fourth and we locate the fourth and the fifth numbers. 1, 2, 3, 4. This is the fourth and this is the fifth. These are the two middle values or middle scores, the two middle scores in the set of observations arranged in ascending order. Now, for the even number of scores, the median is the mean of these two middle values or middle scores. After you locate the two middle scores by this method, you get the mean of these two middle scores or middle values. The mean denoted by this symbol, the median denoted by this symbol is the mean of 18 and 19. That means you add 18 and 19, the fourth and the fifth scores, and divide the sum by 2. The divisor is 2 because we only have added 2 scores or 2 values. And the mean is defined as the sum of the scores divided by the number of scores that are added. And in this example, we have added 2, so we divide by 2. And 18 plus 19 divided by 2 is 18.5. And this is the median. The median is exactly between 18 and 19, between the fourth and the fifth scores. If the number of scores is even, if the number of observations is even, you will find that exactly half of the observations are above the median and exactly half of the observations are below the median. Our sample size is 8, half of 8 is 4. So we have 4 values that are above the median, and this represents 50% of the observation. And we also have exactly half of our sample size 4, and they represent the lower 50% of the observations or scores. That is, if the number of observations or number of values in the given set of data is even, there is exactly 50% of or half of the observations is above the median, and exactly 50% or exactly half of the number of values are below the median. That is, the median for even number of observations or values divide the set of distribution of data into upper 50% and into lower 50%. The median for even number of observations or even number of values divides the set of data exactly into 2 equal parts, the upper 50% and the lower 50%. And that is true only for even number of observations. Now, for these two examples, for cases 1 and 2, we have only a small sample size. What if you have a large sample size, say 121? Example, you have 121 values or observations and you want to find the median of this set of 121 values or observations. Now, do not attempt to arrange them in ascending or descending order manually, use your Excel and let Excel arrange yours, encode the scores in Excel and let Excel arrange the scores for you in ascending or descending order. But to locate the median, we use this method for locating the middle score in the set of scores arranged in ascending or descending order. You add 1 to the sample size and divide by 2. For example, our sample size is 121. That is, you have 121 observations in your set of data. You add 1, 2, and divide by 2. Our n is 121. 121 plus 1 and divide by 2. 121 plus 1 is 122. Divide by 2 is 61. This tells us that, so n plus 1 divided by 2 is 61. That tells you that the median for this odd number of observations, 121, is the 61st score or value or observation from the lowest arranged in ascending or descending order. So if the scores have been arranged by Excel in ascending order, just check out the 61st value. And that would be easy for you because the scores would be labeled. The Excel would indicate how many scores you have encoded from 1 up to 121. And the 61st score in the arranged set of observations, 121 observations, will be your median. And that would be the same also for even number of observations. For instance, your n is 510. Encode these 510 numbers in Excel, and you let Excel to arrange these 510 scores in ascending or descending order. And then you locate the median by computing first n plus 1 divided by 2. N plus 1 divided by 2 for even number of observations of 510 is 510 plus 1 and divide by 2. And 510 plus 1 is 511. And you divide 511 by 2 using your calculator. 511 divided by 2 is 255.5. (511) divided by 2 is 255.5. Now you take the greatest integer or whole number less than 255.5, and that integer is 255. And take the smallest integer greater than 255.5, and that integer or whole number is 256. This means that if the 500 values or observations are arranged in ascending or descending order, you have, because the number of observations or sample size is even, you have 2 scores at the center of the distribution of scores if these scores are arranged in ascending or descending order. And those 2 middle scores or values or observations are the 255th and the 256th scores. Hence, from in Excel, if the values have been arranged in ascending order, just check out the score in 255th score and the 256th score, and you add these two scores or two observations or two values, and you divide by 2. As we have done in this example, if the number of observations is even, you arrange the scores in ascending order or descending order. Locate the two middle scores by computing n plus 1 divided by 2, and add the two middle scores and divide by 2, and you get the median. To summarize, if the number of observations is odd number, there is exactly one value at the center of the distribution of data, and it is the median. And at most half of the median for odd number of observations is below the median, and at most half of the observations for odd number of observations is above the median. For even number of observations or values, you arrange the scores in ascending or descending order. You will find that there are two middle scores, and you can easily locate these two middle scores by computing n plus 1 divided by 2, and you will get a decimal number. Take the greatest whole number less than that decimal number and the smallest whole number greater than that decimal number. And those two numbers are the scores that are in the middle of the distribution of data, distribution of even number of data arranged in ascending or descending order. And the median is the mean of these two middle values. Now, you may have noticed in our examples that in finding the median, we only consider the scores at the center, at the middle. That is, the extreme values, those scores that are high and those scores that are low, are not taken into account when we find the median. And that is one advantage of the median. It is good for finding the average of a set of scores when there are outliers, values that are extremely high or values that are extremely low. And that is one disadvantage for the mean, because the mean takes into account all the values, including those that are outliers, that are either very high or very low in computing the mean. And the mean is affected by these outliers. If there is an extremely high value, it tends to pull up the mean, and when it is there is a extremely low value, this value tends to pull down the mean of the set of data. And but the advantage of the mean is that the mean is used for further statistical analysis, especially in inferential statistics. But the median is not used for further statistical analysis. Next, we will take mode. The third and last measure of central tendency is the mode. The advantage of the mode is that it may be found without calculation or without computation. By inspection of the given set of data, the mode can be found. And another advantage of the mode is that it can be found for both quantitative set of data and for qualitative data. Unlike the mean and the median, they can be found only if the given set of data are quantitative data or numerical data that are obtained by either counting or measurement. But we cannot compute or find the mean and median for qualitative data. Now, the mode is defined as the most popular value or item. If there is a frequency distribution table given, or if you have a set of data and you construct the frequency distribution table for the given set of data, the value or observation or item with the highest frequency by inspection of your frequency table is the mode. Again, mode is defined as the most popular value or item, and in a frequency distribution table, it is the value, score, observation, or item with the highest frequency. The item or the value or observation that occurs the greatest number of times in the distribution of data or in the set of data is the mode. For our example, consider the following. This is a simple, very simple frequency table. A set of medical technology students are participated in a survey and the survey is intended to determine the preference of the medtech students about the color of their uniform. And the choices for the color of their uniform are red, pink, and fuchsia. Among the sample size of 120 medical technology students, 23 of them have selected red for their uniform, and 78 of them have selected pink for their uniform, and 19 preferred fuchsia for their uniform. Now, among these three colors, the color pink has the highest frequency of 78. 78 is not the mode. The mode is pink. Mode is pink. This means that the color pink is the most popular color among the medtech students surveyed, or among the 120 medical technology students who participated in the survey, because pink has the highest or greatest frequency in this frequency table, and because pink was selected by the greatest number of medical technology students. So pink is the mode. It is the most popular color among the medical technology students. Now, in this example, there is only one color that is the most popular among the medtech students, and we can describe this set or distribution of data as unimodal. A unimodal set of data is a distribution of data with only one mode. But a set of data can have two modes. That is, if, for instance, fuchsia happens to have a frequency of 78 also, then the modes are pink and fuchsia because they have the same greatest frequency of 78. And you can describe the distribution of data as bimodal. A bimodal distribution of data is a set of data that has two modes. There are two most popular item or values. There are two values with the same greatest frequency in the distribution of values. And any set of data can have at most three modes. If the distribution of scores has three modes, you describe the set of data as trimodal. But a set of data can have at most three modes, which means that any set of data cannot have more than three modes. The greatest number of modes that any set of data can have is three modes. If a set of data has three modes, that set of data can be described as trimodal. Consider the following example. Now, in this set of data, we have 4 scores and all of them are 88. You can find the mean and median of this without computing. The mean, if you add these 4, 88, and divide by 4, you will get 88. Hence, the mean of this set of data is 88. And the two middle scores are 88. If you add these 2 and divide by 2, you add 88 plus 88 divided by 2, you will get 88. Hence, the mean and the median of this set of data is 88. but the set of data has no mode because the scores are all the same. There is not one score that has frequency greater than the frequency of the other scores. So this set of data has no mode. If in a set of data, the mean and the median and the mode, the mean, median, and the mode are all equal, then you can be sure that the distribution of scores or values or observations is normally distributed. That is one way to check if the distribution of scores is normal. The mean, median, and the mode are all equal and the same. And if you sketch the graph of the distribution of the set of data with mean, median, and mode equal, all equal, the graphical presentation of that set of data with mean equal to median and mean, median are equal to mode will be like this curve. And this curve is known as the normal curve, the graphical representation of a normal distribution. A set of data that is normally distributed and has the property that the mean, median, and mode of a normal distribution of set of data are all equal. And we will get back to this when we go to normal distribution of data. For your practice, please try the following exercises. Find the median and mode. Number 1, the given set of data includes 4, 2, 1, 2, 1, 1, 3, 0. You will find the median and mode of this set of data. To find the median, either arrange these scores or these numbers in ascending or descending order. And then you compute n plus 1 and divide by 2. If the sample size is odd, then you have exactly one score at the center of the distribution of scores arranged in ascending or descending order. If you have an even number of scores, you add 1 to n and divide by 2, you will get a decimal number. And you take the greatest integer less than the decimal number and the smallest integer greater than that decimal number. And these two numbers are the two middle scores. And you add these two middle scores and divide the sum by 2 and you get the median. For number 2, the given numbers are 80, 75, 93, 78, and 50. Again, find the median and the mode. And for you to check your answers, I give you the answers for number 1. The median is 1.5 and the mode is 1. There is only one mode, so we say this set of scores is unimodal. For number 2, the median is 78, but the set of data has no mode. And that's all for today. If you have question about the lesson today, you ask your question in the comments below. And don't forget to subscribe to my YouTube channel, Art Calisan, the channel of learning and pleasure, or ask your friends and classmates to subscribe to my YouTube channel. Thank you for being in my class today.